In this lecture 15 and 16, which says that stability and reliability concerned in the microgrid system. So here mostly I will be discussing about the reliability aspects in the microgrid systems. So this reliability aspects I am going to discussed. So here again I will briefly discuss this topic, reliability analysis of distribution power system with the integration of distributed generation. Okay, so basically again I supervise one PhD student at University of Pretoria, Dr. Temi Tope Adafrati. So he did PhD with me when I was at University of Pretoria. Like he's one of the great researchers. I'm sharing little bit background because he's really when he joined, he doesn't appear to be excellent student. So little bit, aggressive, little bit more impatient. When he joined, he said, I quickly need the data. I will work on the reliability. So I need the data from the power utility ESCOM. Okay. Then I said, you can approach the utility if they can give you. So he wrote the email, or like that morning he wrote email, afternoon he says they have not sent the data. I said, no one is just only serving for you that you write the email and they will send the data. This way it will never happen. Like unless you have very strong connection, it doesn't work that way. Okay, I'm just sharing some of experience. So he tried maybe 1 or 2 days, then he say, okay, I will not do this, this reliability of the conventional power system. Even I suggested that when you deal with conventional power system, the topic will not be very impressive. You will find difficulty in the publication. So I suggest that you conduct the research around the renewable energy integration. Whatever the concept, whatever theoretical background you have, reliability, you analyze with respect of renewable energy integration. Okay, so whatever research we are doing, voltage control, frequency control, fault analysis, so all this research have already been done for the conventional power system. Okay, but with the renewable energy integration, microgrid, this is something newness. Okay, so we are dealing the voltage control problem. It is already solved, but for the conventional power system, with the integration of renewables, how the system behaves. So this becomes something new direction in the research. Okay, so basically here the reliability analysis. So reliability of the power system extremely important. I give an example. I have completed 6 years at University of Sharjah. Okay, so in 6 years, how many times the electricity, failure? I think 1, 2, or maximum 3 times. So basically, this thing is really very important. That the reliability of the power system is there, service is there. You consider any kind of service, residential to some extent, okay, people will criticize, thoda गाली वाली निकालेंगे, but think of the industry. Okay, industrial process will not work. It will have the huge losses. Industrial process, sometime even in the residential system, like say first time when I came, I was there, my wife was there. So we trapped in the lift in 50, years first time. Did you had anyone experience getting trapped in the lift? Any online, please? Okay. So, but it is quite feasible, right? It is quite possible. And some person we think of. So, by the way, you are good luck, you can come out in few minutes. Otherwise, things can be really, big problem. So even my wife will be scared. She will say, okay, 5th floor, I will just go by walk. So these few things, the reliability of the system, that electricity is extremely important. Any operation you consider, okay, sometime it can be, safety issues, threat to the human being. So reliability of the power system really extremely important. So I will just try to discuss some part, but when I talk, I don't just only speak only technical. I little bit chat here and there. So you feel happy about that? I don't know. So here, for example, what are the main challenges in the power sector? How to design a system that will have capacity to supply electric power to its numerous customers economically with an acceptable degree of reliability. I will show you some of the parameters, what is meant by acceptable degree of reliability. Reduced cost of energy. You want to reduce the cost of energy, minimize greenhouse gas emission, reduced annualized cost of the system, reduced maintenance cost, reduced fuel cost. So several aspect reduction with the cost aspect means the economic operation. Okay, and then of course reduce the emission. The 4 objective in the previous slide we were talking. So something like that, you can have multiple objective. You can have multiple objective. So your microgrid could be comprising of your renewable systems, wind, PV, bio, whatever you have. Then diesel generator, load could be residential buildings, etc. So here again in the literature you can see that he has published several very high quality journal publication. I'll just share the experience. Okay, so basically just to encourage our young researcher, that he published several high quality journal. You can search his this Google Scholar page as well. Okay, so he did PhD with me, I think during 2017, something that he completed, 17. So when he was associated with me, I also say that please publish in high quality journal. Okay, so he maintained. Still he is doing research. So whenever he will publish with me, he will only target high quality journal. But when he does on, then any quality journal. Okay, so even I don't do anything in the research, but I just only advise, mentor some of the broader parameters, that the quality is extremely important. Okay, research is same, but where you publish. I give an example that when you have some product like where you sell, what market you sell, how much money you get in return. The research you as the student or the supervisor have to see matching where it has good possibility of publication. I see, many times, I examine so many theses from India and some other country as well. Here I will see that there are very good work, but people end up publishing in poor quality journal. Okay, so it is very important that we target some high quality journal. So this is very important. So here in this, basically you can see like say this microgrid, some literature, this paper published in Energy Journal in 2021. So here architects of this paper, you can see what are the types of problem. Here the abbreviated term you can see here. OP stands for optimization problem, and MOS, what is this MOS? It is multi-objective systems with hybridization of renewable energy resources. So here your architecture of the power system, you can see that it can be grid connected, or it can be off grid. The next topic we are going to talk, I will again briefly talk about the experience of another researcher. He was from India, so I will share a little bit his experience as well. So here the architects of the system could be off grid or grid connected. Okay, then what are the these subcomponents for your microgrid system. Okay, so here you can see diesel generator, CHP stands for combined heat and power. Okay, then photovoltaic system, wind turbine generator, electric vehicles, batteries, pumped hydro storage, and this one more THS or something, you can thermal related some system. So yeah, so you can see that when you are doing some research, okay, so story is basically same. Okay, how you show that it is little bit different, so you consider something additional. So basically what you consider, what is the methodology, what software you use, like say AI techniques, Homer software, very commonly used in the microgrid. I hope everyone aware of Homer. Okay, then MATLAB, Simulink, some integer programming, and so there are so many techniques. Then at the end, what are the performance indicators? Okay, so this could be like say optimization cost. Okay, cost minimization, emission minimization. So this way you have the several performance indicators. Okay, then very interestingly, when we are talking about the reliability, I think everyone have heard the name about the Roy Billington. Anyone heard the name? Reliability. So is the big person in the reliability. So if you say Roy Billington, you Google it, Roy Billington, his name will come. He is big person in the reliability. Okay, so is the anonymous to the reliability. Okay, so basically when we have this reliability, then there will be several reliability index parameters. Okay, like for example, average failure rate, how many time system is failing. Okay, then average outage time, when the failure occurs, as an average, how much duration this failure is there, like 5 minutes, 10 minutes. So what is the average failure rate? This way, then for example, system average interruption frequency, called as the SAFE failure, SAFE. System average interruption index, SAIDI. So this way you will find there are large number of reliability index parameter. How you will judge that the system reliability is high? So there will be some performance index. You will compare, you will analyze the performance index. So this table coming from here, I mentioned yesterday, the review paper written by the same researcher. So in that, this reliability index are very nicely documented. Okay, I'm not going through each and every aspect. When you have this like this renewable energy, there can be several benefits. It can improve the reliability. Even he used to say that reliability will improve. So then I initially felt little bit confused. I say, how the reliability will improve with the renewables? Renewables are highly unreliable. But he will have his own way of nicely documenting. Okay, and he will nicely document, like say environmental benefits. You can say environmental benefits, you can list them: reduction of CO2, reduction of NOx, reduction of SOx, right? So you can GSD reductions, you can list down how you can document. Okay, then economic benefits. Okay, it could be reduction of COG, cost of energy, reduction in the fuel cost, reduction in the maintenance cost, reduction of the net present cost. So basically you can expand. So here basically in power system, as we know that using the fossil fuel is a problem, causing the environmental issues, and that's why we go for the integration of renewable energy sources with energy storage system in the power system. And this is achieved by analyzing reliability, environmental and economic impacts of the renewable energy sources in the power system. So here the World Bank record on the indicators to measure the reliability and provision of the infrastructure services in some of the countries as presented in the table. So here in this table you can see, get an idea that indicators of the electrical infrastructure reliability. Okay, so different countries, different region, as an average all countries, East Asia, Eastern Europe. So different countries, you can see electrical outage losses when there is power failure. So how much is the electrical outage losses? So you can see this factor in the different region varying significantly. Okay. Number of electrical outages in a month. So in this also, like you can see, compare for example in African continent, quite high, okay, almost one outage almost every day. Okay. So if you compare with respect of like say some other countries, it like say less than one outage in whole month. Okay. So this way you have the different indicators for the reliability, duration of electrical outage. So this duration you can see is also significantly varying. So here overview of the reliability assessment. Reliability is the probability that power system will perform its function adequately without any failure with a stipulated time of the period of time when subject to normal operating condition. When you are operating under normal conditions, you consider any device. Okay. So it will perform its intended function without any failure for the stipulated period of time under the normal condition. So reliability is the degree at which performance of the components of the power system result in conveyance of electric power system to the customers with acceptable criteria and the amount of anticipated for intended period. Reliability is the key performance indicator in planning, design and operation of power system. Reliability assessment has become a significant subject due to the sudden increase in the demand of reliable power system at minimal frequency and duration of power outage. So this reliability in the power system is used by the power utility to measure the performance of the power system. It is used to analyze the impact of the power interruption on the number of customers at load points and the cost that is associated with the power outage. It is used to estimate the substantial impacts of renewable energy sources in the power system. It is utilized by the utilities to determine the balance between the economy and continuity of the power supply. So here when we are talking about the distribution of the power system, because when we are talking about the generation, talking about the transmission, talking about the distribution. Okay. So the outage mostly will be in the distribution system. You will not see that much of outage in the generation or that much outage in the transmission. If you see like the outage in the transmission line, so it will affect the significant part of the distribution. So most of these outages you will see in the distribution. So here distribution system is technically, as we know, that last segment in delivery of the power system at load points. Stats show that failure in the distribution system is about 80% outage of the total power system. This has demonstrated the need of frequently perform the reliability assessment of the distribution system. Even we have the microgrid which is connected in the distribution system. So considering its reliability becomes very important. So here you can see that when we have this like the uh, uh, this transmission or generation, shall see that outage duration is quite low, but when we have this lower voltage coming to the distribution, these outage durations become significantly higher. Okay, so most of the significant outages, it will be in the distribution system. Okay, so here when you want to have some analysis, you want to carry out the study, you will have some network, either some realistic practical network, or you can have some standard IEEE network system. Okay, so that researcher found this RTBS. RTBS stand for the RBTS. RB stand for Roy Billington, the key person I explained on the Roy Billington. So system based on his name. So you have this like this network, and then of course you want to integrate the renewable energy sources at the different buses, like you integrated wind system, you integrated PV systems, suitable locations, you have the diesel generators, okay, then you want to analyze this system. Okay, then of course you are going to model these microgrid systems. What will be your objective? I'm not going into the detail. So objective could be minimization of the cost of the energy, annual cost. You want to optimize. There can be multiple objective for the cost minimization. Then of course it will have some constraint that how your this power system will operate. Each generation will have its maximum and minimum operation constraints. So you appropriately model the power system. I'm not going into the details of that. I just want to little bit give you an idea. So here you have a system. Here the system is, you can see, quite large. The load on the system, you can see here something between 15 to 20 megawatt load, and then that load you are going to use through this a PV system, wind turbine, battery storage system, and of course the diesel generator. So here in first case you are mainly using this load requirement through the diesel generator. Then as compared to the first base case, when you are only using the diesel, then you start using these renewables like PV, wind. You try to have the minimum use of the diesel generator. Okay, so we have to understand the profile of the PV. So you can see that PV is generating power, say early morning around 6 or 7 to, say, depending upon where you are installing the PV system, goes to say 6 PM in the evening. So it is generating this power. You can see this power production from PV. Then you have this wind. So how this power production from the wind will be there. Then you have this like the battery storage system, and you will again see the state of charge of the battery. state of charge of the battery. As you are using the battery storage system. So basically, and then of course you have the diesel generator. Okay. So when we have this power production from the photovoltaic, so you can say during the day the diesel generator use becomes minimum. Okay. If you see as compared to previous one, you see that when we are not using the PV or wind or even the storage system, so mostly the load is met mostly by the diesel generator. Okay. So when we are using these renewables, then to meet the load, we are using the renewables to have the minimum use of the diesel generator. But of course, we will have the constraint that battery storage system we will using that it stays between the state of charge minimum and maximum. So all the constraints we have to be considered. PV will be available mostly during the day. Okay. When wind is blowing, we will be able to generate the wind power. But we are optimizing this, so basically it should able to continuously satisfy the load demand. Yeah, so then basically you can have the different scenarios. You can have different scenarios for the different cases I mentioned. You can have only diesel. Then in diesel you add the storage system. You have the different case studies, and then of course you are optimizing the different cost aspects. So you can see these results. I am not going into the detail, but just to present you a little bit idea in the tables. For example, impact of incorporating the wind PV battery system on the annualized cost of the system. Okay, you are considering the different scenarios. Okay, first one is like just you are considering diesel. Okay, so how much is the cost of energy? But when you are incorporating renewables, so the cost of energy is significantly reduced, around 50%. Then impact of incorporating number of wind turbines, PV, battery storage system on the annual emissions and fuel consumption. Okay, so what is the impact on this aspect? You see, in the first case, we were using mostly the diesel generator. So you can see how much is the diesel generator fuel consumption, the fuel like 404, at least figure you can see. Okay, but when we are using the best case with renewables, so it comes down to around 100. So 1/4 diesel is being used. Okay. Then accordingly you will see that when the diesel use is getting just around 25%, then whatever you have the CO2 emission, first case CO2 emission was close to say 1960, then it comes down to around say 263, 1/3. Okay, so emission reduction is like 1/3. Same way SOx and NOx. So you can clearly see, which is obvious as well, that how much diesel you are using, how much is this cost of that. When you are incorporating renewables, how much renewables you are incorporating, accordingly it will leading to the reduction in the cost. It is leading to the reduction in the fuel, reduction in the emissions. And then talking about the reliability of the power system. Okay. When we have incorporated the renewables, okay, so we may think that system will not be reliable, okay, but we have to judge based on this reliability index parameters. Okay, so there are several reliability index parameters. So several reliability index parameters have been dealt, that this electrical energy not supplied, cost of that, okay, total outage cost, total cost of electrical energy not supplied, emission costs, okay. So all these different reliability index parameters you are considering. So basically you can see that as we are integrating renewables, the reliability of the system is significantly improved. So here a detailed analysis is carried out. I am not going into too much of detail. Okay. So here this is another example dealing with the this researcher Temitope Adaferete. So is talking about the reliability, economic and environmental analysis of microgrid system in the presence of renewable energy sources. So this paper published in the Applied Energy Journal, which has very high impact factor, around 9 I think 10, or I think something like that. And this paper received the highly cited research paper as well. So, and here what we are talking, that renewable energy integration in the microgrid, but microgrid not very small in terms of like up to 1 megawatt or half megawatt, but you can see that here research is conducted based on this quite significant size of microgrid. You can see that both small and large systems have been studied. So for this configuration, what it is given in the like again the configuration economic analysis has been carried out. I am not repeating. This case talks about the analysis for a large isolated microgrid system. So this paper, technical, economic and environmental assessment of distribution power system with the application of renewable energy technology, published in the Renewable Energy in 2022. So here the techno-economical analysis of the renewable energy technology in microgrid system is carried out. Here the wind and solar resources for the location in the northern Cape Town in South Africa province, and the sequential hourly shape of this IEEE reliability test system with the peak load of 40 megawatts. So you can see that it is quite significant size, whatever you call the microgrid system. Okay, so is considered. So here again 5 scenarios are analyzed by using the economic, emission and reliability indicators of power system with incorporation of diesel generator, photovoltaic, wind, energy storage systems. So again here we consider the network system, and then we incorporate the renewable energy sources of the appropriate location, appropriate sizing. So here the diesel generator rating 48 megawatt, the PV considering 24 megawatt capacity, wind we considering 24 megawatt, and energy storage system considering 4 megawatt. So this way we are considering the 5 different cases, and then again we want to see the objective function. Objective function, it is a objective function. Here it tries to minimize the total outage cost, TOC, total outage cost, minimize the reliability index. This TAC stands for the total annual costs, and EIR is the environmental impact reduction cost. So here it is considering the reliability aspect, the cost aspect and environmental aspect. So it is a multi-objective function. Okay. So here this table provides the data taken from these references. You have diesel generator, wind turbine, photovoltaic, energy storage system, inverters. How much are the cost? So diesel generator says $2,700 per kilowatt. This is the initial cost. Maintenance cost is $0.01258 per unit of electricity. The lifetime of diesel generator 25,000 hours. Some other factors are provided. Wind turbine, initial cost $3,500 per kilowatt. Maintenance cost $20 per kilowatt per year. The lifetime is 25 years for the wind and PV system. So this way all parameters are provided. Then you are analyzing the system. Total cost of the system you can see here in this graph. We consider the different scenarios, like say first only like the diesel, then we kept on adding the renewables, PV, wind, energy storage system in sequence. So here you can see that this cost here in this last scenario obviously coming down, and here in this table you can also see these different cost aspects. Costs are reducing, cost saving is there, which is presented in the detail in the table. Then you can see the effect on the emission for these different scenarios, that CO2 emission, as you see for first case 1 1920. Here it comes like 538. So just like 1/4. Same way this SO2 and NOx emission reduction is there. You can also see that about the fuel consumption, what you had in scenario 1. So first, like the first 4 figures you see coming closer to 10,000. Here, if you see in the last case, first 4 figures less than 2,500. So fuel used is just like 1/4. So you can see that you are using in first case this much of fuel, then how much fuel you have here. So 70%, approximately 70% fuel saving is there. So you can see 75% fuel saving is there. Talking about the reliability index parameters. So you can see how many these reliability parameters are considered. So all these you can see reliability parameters considered here, SEFI, SEDI, KEDI, so etc. So you can see that I am not going into the detail because of the time constraint, but you can see that with the integration of renewables, reliability is also significantly improved. And with you can see how the system is operated, maintained very well. Okay, so here this student, I'm sharing his presentation. This is the author in all the first paper. So he did PhD with me. So if you see from the down, first paper he wrote like the review paper that I showed you, the review of the distributed generation. Then you have the paper in applied energy, reliability assessment of distribution system with renewable energy integration, applied energy. Then another paper, reliability and economic aspects of microgrid system with integration of renewables. Then you can say reliability, economic and environmental analysis. Okay, what you consider something additional, your rewrite is almost complete. You do the fresh writing. Then you can say optimal energy management for PV, wind, battery storage system, microgrid system, technical, economic and environment assessment of the distribution power system with renewable energy technologies. This paper talks about the optimal energy management and technical, economic, social, political. See how many factors are being considered. Technical, economical, social, political and economical benefits analysis of grid connected PV, wind, fuel cell, hybrid energy systems. And then very recent this one, design and techno-economic assessment of standalone PV DG battery storage system for electrification of rural areas. So I briefly presented the research work from this student. So I just will conclude this presentation, but some papers I will try to share, and if anyone needs more paper, I will be happy to share. So I will just for this presentation I will stop here, but I will be happy to provide any questions you have, maybe technical, economical, general. Okay, so you are more than welcome to ask. As you will see that I My job only is to encourage publication in high quality journals. Okay. So this is very, very important, So even you can search for this person, Google Scholar. If you will find where my name is not there, so quality of journal will generally be reduced significantly. Okay, you can search it now itself, Google Scholar page. So please ask few questions. Any question, please?
I'm Manveer from Thapar Institute of Engineering and Technology, Patiala, Punjab.
Yes, excellent.
Sir, I have one small question, sir. When we are considering the reliability tax with respect to the multiple sources involved in the system, then are we assuming, because the renewable energy sources are not certain in nature, so are we considering that these sources are available before taking out the generation adequacy?
Yeah, so that initially, as explained, like how different reliability index parameters are defined in the literature. For example,
yes. Actually, this topic seems to be very interesting to me, and I would like to see your paper as well.
Yes, most pleasure. You can just message, email me. I will be happy to provide the papers. So, but you can see that how this reliability, different reliability index parameters are defined when we have this microgrid system with the integration of different sources. So system becomes more reliable. The failure of microgrid as such will be less because there will be, if the system are in parallel, you are adding the generators in parallel. If you have the system in parallel, it will increase the reliability. Of course, if you are adding the component in series, it will decrease the reliability. Okay. So all these, yes.
But for renewable energy sources which are uncertain nature, so we are assuming that these units are available to share the load demand.
Yeah, so basically, as you'll see, that very interesting point you asked, that we, for example, how we are meeting the load. Okay, so you can see that photovoltaic generally will be available during the daytime, and as the sunshine keeps on changing, accordingly you can see the power contribution from the photovoltaic system accordingly. Then
okay, so based on the time interval, in a given time interval, we are considering the units and we are carrying out the generation adequacy performance.
Yes. So here also, like you can see, same way, what is the wind profile, accordingly how much the power is being contributed by the wind turbines. So all these things, like based on the availability of the data, availability of the information, and we are trying to optimize our program, meet the generation with the demand. Okay. So we ensure that the system frequency is maintained, and that's something with the certainty, like how much we are providing through the battery storage system within the limits of the SOC. So we are doing that. And if there is like say less power from the renewables, that we are meeting either from the batteries or from the diesel generator.
So this sampling time we have taken, I have not seen that, the axis is not visible. Sampling time? Hours.
Yeah, so maybe this all in different papers, the studies are quite detailed one. So I have just presented very briefly. If I present this whole, it can take 5 days just talking on the reliability.
Actually, I am student of Professor J.S. Dillon.
JS Dillo, yes, I heard from the JS Dillo again, the student of Professor DP Kothari.
Yes, yes, yes.
I'm also the student of Professor DP Kothari.
DP Kothari and J.S. Dillon are my supervisors for PhD.
Okay.
And DP Kothari recommended your name for as one of my student examiners, but your name was not taken.
Yes.
Unfortunately, your name was not
No problem.
taken.
Like you see, yesterday we talked regarding the collaborative. The point one we mentioned, it is not always that you'll have MOU, but there could be
Yes.
when you have some link, some collaboration, you can have several. For example, anyone consider potential examiner, for example, or for example you want to have some conference, for example US or some other location, you explore maybe some possibility how it will be presented. So there are different possibilities when you have some networking, it is really
Yes.
very helpful.
Yes, such type of GIAN courses are helpful for social networking as well.
Social, and then of course technical knowledge, condensed knowledge.
Practical knowledge is always basic, but social networking as well.
Yes. So like in 5 days you can have significant condensed knowledge, resources.
Yes.
And which depending upon your research interest you can further build up.
Find the direction. Yes, help us to find the direction.
Yes.
Thank you so much.
Thank you much.